Hello everyone! I'm thrilled to introduce to you the dynamic duo who have been instrumental in bringing this project come to life. Let me introduce first, I am Shane Ashley M. Manadan.
And I am Ruth A. Poblete. Together, we have combined our diverse skills and talents to create something truly special. We hope you find our project as exciting and beneficial as we do. Today, we're going to present to you a project that our team has been diligent to work on.
This project, which we named Multicalcufy System or MCS, was conceived with the aim of providing a tool that performs mathematical calculations quickly and accurately, but not just like other calculators because we add more features.
We pick some of operations or unit of measure that is not easy to calculate, such as how to get the velocity, pressure, force, kinetic, acceleration, and density.
We designed this to simplify complex computations. Before knowing the solutions of its features, we are required to perform so many calculations before getting the answer. That's where our project comes in.
So let's start with the demo of project. This demo provides a basic framework for showcasing the Multicalcufy system functionality and guiding users through the calculation process.
User input. User will choose one of the 11 operations they want to perform calculations for. There is a step-by-step guide for users on how they will perform the calculations for that specific operation. User input answers. The user will provide the necessary values or inputs required for the operations or unit of measures they choose. User must be input the values that is needed and correct. The system will conduct a calculation based on the user selected operations and the provided inputs. Display result. The system will present the calculated result to the user in a clear and understandable format. System will invite the user to try also and explore other operations or calculation by showing again the list if they have additional questions or needs. Additional features. System shows error handling for invalid inputs or operations.
Let's proceed to the demo of codes. Here's the libraries or header file library that we use. These are preprocessor directives.
First is IOStream. The standard input-output library provides input and output functionality using streams. Next is CMath, the math library. We use this because we'll perform some math-related functions. Then, CSTDlib, general purpose standard library. We also apply this to make the program pause a while before running again. And lastly, the stdlib.h.
Before starting to create codes, first we must declare variables using data types.
We choose to apply float to declare the variables tm, sum, diff, prod, co, ans, vel, tsr, frc, knt, acl, and dst. We also use the data type int that have the variables I, n, number, num, and choice. And lastly, the data type double with the variables called num1 and num2.
Let's start with the calculator selection menu.
There are 11 options or operations for you to choose from to perform calculations. In addition to the common features of calculator such as addition, subtraction, multiplication, and division, we came up with this idea that we will introduce additional operations or features to provide easy access to solutions for unit of measures to avoid the hassle of manually solving a specific properties of objects.
So first, in the selection menu is the addition.
This prints addition with some spaces before it. This is called the print function again. This asks the user how many numbers they want to add. This reads the user's input and store it in a variable number. This prints enter number where number is the user input. This declares a loop that repeats number times. This reads a number from the user and store it in a variable number. This adds a number to a variable sum which keeps track of total sum. This prints the sum is sum where the sum is the final result.
Next is subtraction.
This calls the print function. This prints subtraction with some spaces before it. This calls the print function again. This asks the user how many numbers they want to subtract. This reads the user's input and stores it in an n variable. This prints enter n numbers where n is the user's input. This declares a loop that repeats n times. This reads a number from the user and stores it in a variable number. This checks if this is the first iteration of the loop. If yes, then it assigns the number to a variable diff, which keeps track of the difference. If not, then it subtracts the number from the variable diff. This prints the difference is diff, where diff is the final result.
And followed by third case of the switch statement, which performs multiplication.
Print function. This prints multiplication. Print function again. Ask the user how many numbers they want to multiply. Read the user's input and store it in a variable n. Prints enter n numbers where n is the user's input. Declares a loop that repeats n times. Reads a number from the user and store it in a variable number. Check if this is the first iteration of the loop. If yes, then it assigns the number to a variable prod, which keeps track of the product. If not, then it multiplies the number with the variable prod. Print product is equals to final result.
After multiplication, there is division.
Print function. Prints division. Prints function again. Asks the user how many numbers they want to divide. Reads the user's input and stores it in a variable n. Prints enter n numbers where n is the user's input. Declares a loop that repeats n times. Reads a number from the user and stores it in a variable number. Checks if this is the first iteration of the loop. If yes, then it assigns the number to a variable q, which keeps track on the quotient. If not, then it divides the number by the variable q. Print quotient equals the final result.
The square of the number is the fifth case of the switch statement.
Print function. This prints square of the number. Print function again. Ask the user to enter the number they want to know the square of. Read the user's input and store it in a variable n. Declares a loop that repeats 1. Print the square root of I is I multiplied to itself to get the square root of I.
This is the sixth case of the switch statement, which calculates the average of some numbers.
The print function. This prints get an average. Print function again. Ask the user how many numbers they want to add to get the average. Read the user's input and stores it in a variable number. Declares a loop that repeats until n is equal to number. Prints enter number. Reads a number from the user and stores it in a variable num. Adds the number to a variable ans which keeps track of the total sum. Increments the variable n by 1. Prints the average is ans number where ans is the sum and the number is the count.
And the seventh case of the switch statement is the velocity.
Print function. This prints velocity. Print function again. Ask the user to enter the distance in meters. Reads the user's input and store it in a variable num1. Ask the user to enter the speed in seconds. Read the user input and store it in a variable num2. Calculates the velocity by dividing the distance by the speed and store it in a variable velocity. Prints velocity is equals to vel meter per second, where velocity is the result.
In this case 9 calculates the force, which is the product of the mass and acceleration.
It prints the word force and asks the user to enter the mass and the acceleration and store them in a variable num1 and num2. It then calculates the force by multiplying num1 by num2 and assign the result to the variable FRC or force. It prints the force with the unit of Newton, which is in the standard of unit force. It then breaks out of the switch statement.
Inside case 10 is the kinetic energy, which is the energy of motion.
It calls the print function, prints the word kinetic energy, and calls the print function again. It asks the user to enter the mass and the velocity and stores them in the variables num1 and num2. And then calculates the kinetic energy by multiplying half of num1 by the square of num2, and assigns the result to the variable knt or kinetic energy. It prints the kinetic energy with the unit of joule J, which is the standard unit of energy. It then breaks out of the switch statement.
Next is case 11. This case calculates the acceleration, which is the rate of change of velocity.
It calls the print function, prints the word acceleration, and calls the print function again. It asks the user to enter the initial velocity, final velocity, and the time, and store them in the variables num1, num2, and time. It then calculates the acceleration by subtracting num1 from num2 and dividing the result by the time, and assign the result to the variable acceleration. It prints the acceleration with the unit of meter per second squared, which is the standard unit of acceleration. It then breaks out of the switch statement.
Second to the last case is the density, which is the mass per unit volume.
It calls the print function, prints the word density, and calls the print function again. It asks the user to enter the mass and the volume, and stores them in the variables num1 and num2. It then calculates the density by dividing num1 by num2, and assigns the result to the variable dst or density. It prints the density with the unit of kilogram per cubic meter, which is the standard unit of density. It then breaks out of the switch state.
And then the default case.
This case is executed when none of the above cases match the value of the expression. It prints the message unknown selection and breaks out of the switch statement. This case is optional, but it is good practice to include it to handle unexpected inputs.
After the switch statement, the code calls the system function with an argument pose, which poses the execution of the program until the user presses a key. It then prints the message end of program and thank you for using Multicalcufy. It then returns 0, which means the program terminates successfully. The last part of the code defines the print function, which is a user-defined function that prints a line of a symbol to separate the output. It takes no parameter and returns nothing. It uses the cout object, which is used to output data to the standard output device, usually the screen.
And that's it, the short video presentation of our project, Multicalcufy system. Thank you. Bye-bye.